we wanted to go over number 15 and 18. So we'll start with that. And if anybody wants anything else, we will go over those in just a bit. Okay. Okay, there we are, 15. CrOH3 goes to CrO4, 2 minus, and we want that in basic solution. Okay, so step number 1, we are going to balance the major atoms, which in this case is the chromium, our non-hydrogen, non-oxygen. Non-hydrogen, non-oxygen. It's done. So we don't have to do that. Step number 2, we're going to balance oxygen with water. Okay, so on the left-hand side, we have 3 oxygens. And on the right-hand side, we have 4 oxygens. So we will have OH3 goes to CrO4, 2 minus, and we will need to add another water onto the left-hand side to give us now 4 oxygens on the left-hand side. Okay, so step number 2 is done. Step number 3 is, let's see, we want to balance hydrogen, so major OH, and we balance that with H plus. So on our left-hand side, we have 2 hydrogen, and we have 3 hydrogen, for a grand total of 5 hydrogen. On the right-hand side, we have no hydrogen. So we're going to have to add 5 hydrogen to the right-hand side. So that would be H2O plus CrOH goes to CrO4, 2 minus plus 5H plus. Okay, step number 4. We are going to balance the charge with electrons. So we need to find the side which has too much positive charge. So our charge on the left-hand side is 0, and our charge on the right-hand side, we have 2 negative, and we have 5 positive. So that gives us a grand total of 3 positive. And so we need to add 3 electrons to the right-hand side because we need to bring this down to 0 so it equals the other side. So we would have H2O plus CrOH. 3 goes to CrO4, 2 minus, plus 5H plus 3 electrons. And now before I go on, I'm just going to check. I have 4 O's and 4 O's. I have 2 plus 3 is 5 H's and 5 H's. I have a total charge of -5 and +5 is 0, and I have 0. So it's looking good. Now we are asked to make it basic. So step number 5, to make it basic, we are going to add OH minus to both sides. How many? It's going to be the same number, same number as hydrogen, because we want to neutralize all the hydrogen with hydroxide. So we're going to neutralize these 5 hydrogen here with 5 hydroxides. But because this was a previously balanced equation, if I add something to the right-hand side only, that will unbalance it. So we also need to the left-hand side to add 5OH minus. Okay, and step 6, we're going to add together. So we have H2O CrOH3 plus 5OH minus goes to CrO4 2 minus plus 10 H2O plus 3 E minus. And now I need to cancel anything I need to cancel. And in this case, I have hydrogen, or sorry, not hydrogen. I have water on both sides. I have one water on the left, so I can cancel that whole thing. And I can cancel one of the waters on the right. 5 waters on the right. Oh my God, what's wrong with me? That should have been 5. Okay, so there we go. 5 waters, so we can cancel one of those and we will get 4 waters. And at that point, we should be done. And hopefully my answer key reflects that. Let's just go look. 4, 3, 1, 5, yes. Okay. And if we were asking you if this was oxidation or reduction, you could take a look at that and you could say, hey, look, I lost electrons, they came out, and therefore it was oxidation. Okay, you don't have to, if you're doing the work, you don't have to show every step on a different line. You could have, say added your water up here and added your hydrogen then over on the other side, 5H plus, and then 3 electrons, and then you could have just made it basic from there. I wanted to be able to show all the work and how I was doing the process, so that's why I wrote it out so completely. But like I said, you might not need to do it that completely. Okay, excellent. So that was number 15. Now we're going to look at number 18. Number 18. And we have, sorry, I'm just scrolling through on my other computer here. We have FeHPO3, FeHPO3 goes to PO4 3 minus plus FeOH3. Whoops, that didn't look very good. The bracket took over the H. FeOH3. And we want to do this in basic solution. So number 1, major. Remember, it's major OH says charge, and we balance that by coefficients. We balance oxygen with water, and we balance hydrogen with H plus, and we balance charge with electrons. And when you get to the end of that, you are done acid, and then you can change it to base. All right, so let's do this one. We have step number 1, phosphorus is our major atom. Oh, we actually have phosphorus and we have iron. That's okay, as long as we make sure I have 1 phosphorus, 1 phosphorus. I also have 1 iron and 1 iron. I could have changed any of the coefficients if I needed to, if those weren't already balanced. So step 1 is done. Step 2, balance oxygen using water. Over here we have 3 oxygen. Over here we have 4 and 3 is 7 oxygen. So we will need to have an extra 4 oxygen on the right to give us a total of 7. So we'll need to add 4 waters. So we're going to have 4 waters plus FeHPO3 goes to PO4, 3 minus, plus FeOH, whoops, FeOH3. Good stuff. Okay. So we have done oxygen. Now we need to do hydrogen. Okay, so we have 8 hydrogens, or 8 hydrogens, and here we have 1 hydrogen. So that gives us a grand total of 9 hydrogen on the left. And over here on the right, we only have 3 hydrogens. So we will need an extra 6 hydrogen on the right-hand side. So just rewriting 4H2O plus FeHPO3 to PO4, 3 minus, plus FeOH3 plus 3H plus. And that gets us through step 3, and step 4 is going to be our charge. 3 negative, 3 positive. Oh, hang on. What have I done wrong? Oh, I don't need 3. I don't need 3 hydrogen. I have 3 hydrogen and I want to make 9 hydrogen. So I don't have 3 hydrogen. I would need to add 6 hydrogen. That would give me a grand total of 9 on the right to match the 9 on the left. Okay, that makes more sense. So if you get to the point where you're trying to balance the charge in a half reaction and you're like, oh, the charge is already balanced. If it's a half reaction and they've asked you to balance it, you must have done something wrong, because there will always be electrons in a half reaction. So I knew I had done something wrong, and lo and behold, I found it. I found that I was trying to add 3 hydrogens when I needed to add 6. Okay, so now our charge on the right will be 6 plus and 3 minus. Gives me a grand total of my charge is going to be 6 positive over on the right, and on the left my charge is 0. Because I'm adding electrons, electrons are negative, so I need to add them to the more positive side. So I'm going to add 6 electrons to the right-hand side. So 4 H2O plus FeO3 goes to PO4 minus plus FeOH3 plus 6H plus, and I need 6 electrons to give me 0 charge like I have on the right-hand side. And that finishes us in acid. Step number 5, we're going to convert into base. And I'm just going to squish this down a little bit so I have a bit more room, because step number 5 is add OH to both sides. How much? Enough to neutralize all the H plus. And in this case, we have 6H plus. So we need to neutralize that by adding 6 hydroxide. And then on the right-hand side, we need to add 6 hydroxide. And that will give us, now we're going to add it up. So we have 4H2O plus FeHPO3 plus 6OH minus goes to PO4, 3 minus plus FeOH3 plus, and now these two combine, the hydrogen and the hydroxide. Whoops, forgot my charge there. The hydrogen and the hydroxide combine to give us 6 waters plus 6 electrons. And again, we're seeing the electrons are coming out. So that will be an oxidation. Okay, losing electrons, oxidation. And what can I cancel? I can cancel some waters. I can cancel 4 waters, which will leave me with 2 over here. And let me go check on my answer key, see if I did that the same. Yes, that looks, oh, hang on. Why do I have 3 electrons over there? Oh, no. Oh, oh, I messed up my charge. I see. Over here, I said I have 6 positive, but I don't actually have 6 positive. I had 6 positive and I had 3 negative. So I don't have a 6 positive charge on the right. I have a 3 positive charge on the right, which means instead of 6 electrons, I don't want to have 6 electrons. I want to have 3 electrons, which means down here, I'm also going to have 3 electrons. Okay. It is so super easy to make like a stupid little mistake. So don't beat yourself up if you make a stupid little mistake. Just be like, okay, next time I need to be more careful. I'm always telling myself that 30 years later, next time, be more careful, Karen. Okay, so just, keep doing it. Are there any other questions before we go on to a couple more examples of full reactions? That is a resounding silence. Okay then. Well, now let's just review our steps for balancing full reactions. Number 1, you cannot just balance a full reaction. You must split into half reactions. I would say 50% of the people who get these wrong forget step 1. Okay, so like star it, highlight it. If you forget to do step 1, you'll just balance it like we did with our half reaction, and you're going to end up with electrons somewhere. And because we're doing a full reaction, we shouldn't have electrons in the reaction. There should never be electrons in the reaction at the end. No electrons in overall reaction, because we should be making the number of electrons being given off should be being accepted by the other substance. They should equal. Okay, so split into 2 half reactions and then balance the half reactions, just like we did in those last couple examples. Balance the half reactions. And if you're asked to make it basic, you could make it basic here. Or you could wait till the end. I tend to wait till the end. I'm just putting it here because some people do it, and it is okay to do that. Okay. Step number 3, balance the half reactions. You're going to make the electrons, the number of electrons going out or being lost, equal to the number of electrons going in or being gained. And this is so you will have no electrons in the overall reaction. So the electrons going in will cancel out the electrons going out. And you do that by multiplying the half reactions to get the LCM of the number of electrons. What's an LCM? Lowest common something. Yeah, it's the lowest common multiple. Yeah. Okay, so that's going to be the lowest common multiple. Okay, and then you are going to, step number 4, add the reactions back together. Back together. So split them apart, then bring them back together. And you're going to cancel anything that needs canceling. And then if you need to make it basic, you could make it basic here. You can make it basic here as well, which is where I tend to do it. I tend to do it sort of after step number 4. Okay, and then I would of course do any further canceling. So actually there's not a lot of steps. If you know how to do this balancing half reactions part, there's really not much to it, but you do have to remember to split them up, make the electrons in go equal the electrons out, and add the reactions back together and cancel everything out. So shall we do an example? Let's do that. Super exciting. Okay, for example, I want to, oh, can I do that? Let me see if it works. Oh, so exciting. Okay. Oh, no, here we go. Okay. So we have Cr2O7, 2 minus, we have dichromate, and we have HXeO4 negative. I have to be careful and watch out that I don't forget my negatives as I go along and copy it out. Goes to Cr3 plus and HXeO6, 3 minus. And just before we go on, if we were to look at this, and if I said, what is happening to the, this is just by way of review, what is happening to the chromium? Is chromium being oxidized or is chromium being reduced? And how can you tell? Okay, so the first way you could tell, since I'm getting absolutely no response, I don't think. Nope, no response. Okay, you could tell you go from Cr2O7, 2 minus, to Cr3 plus. So you could look at the oxidation number. Okay, over on the right-hand side, that's easy, it's 3 plus. Over on the left-hand side, we have 2 chromium plus 7 oxygen equals -2. Okay, so we have the number of each element equaling the overall charge. We have 2 chromium. The oxidation number for oxygen is, what's the oxidation number for oxygen? Yeah, it's -2. Good stuff. Okay, so it's going to be -2. Oops, why did my negative not show? There we go. -2. So we will have 2 chromium minus, oops, that should be a big C, minus 14 equals -2 plus -14. And then that gives us 2 chromium is equal to +12, which means that chromium is equal to +6. So we went from chromium on the left-hand side having an oxidation number of +6 to on the right-hand side having an oxidation number of +3. So answer to yourself, was chromium oxidized or was it reduced? the oxidation number got reduced. It got smaller. When the oxidation number gets reduced, you had reduction. Okay? I could have also guessed that simply from the fact that I had a whole bunch of oxygens here, and now I don't have very many oxygens, so the chances of that being oxidation are very low. Usually if I throw oxygens onto something, I'm getting oxidation. If I take oxygens off of something, I'm probably getting reduction. Okay? We won't do the same thing for the other species, but you could. Okay? So we are going to isolate our half reactions. One half reaction involves chromium. The other half reaction involves xenon. So our two half reactions are, step number one, our two half reactions are Cr2O7 2 minus, I'm going to leave a little space there, goes to Cr3 plus. And our other half reaction is HXeO4 minus goes to HXeO6 3 minus. So now, step number two. So step number one was split into the two half reactions. And step number two is to balance the two half reactions. So step number one, major. Major is chromium for our first reaction. So we're going to do the first reaction first. So there our major is balanced. Oxygen comes next. So we need 7 waters. On the right-hand side, we have 7 times 2 is 14 hydrogen. So on the on the left-hand side, we need 14 hydrogens. And then my charge on the left-hand side is 2 negative and 14 positive for a grand total of 12 positive. On the right-hand side, I have 2 of the chromium 3 plus, so it's going to be 2 times 3 plus, which is going to be 6 plus. So I have more positive charge on the left-hand side. And that means that I need to add electrons to the left-hand side. And in this case, I need to add 6 electrons because I want to equal 6 positive. I start with 12 positive. I take away my 6 negative, and I end up with 6 positive. The two sides now have equal charge. Okay. I balanced the first half reaction. Now balance the second half reaction. Major. Major is xenon, 1 on each side. Excellent. Step 1 is done. Oh, well, I got 6 O's on the right-hand side and 4 O's on the left-hand side, which means I need to have 4 waters on the left-hand side. Is that right? No, it's not. I need to have 2 waters. That's going to give me 4 plus 2 equals 6 hydrogen, or oxygen rather, to match the 6 on the right. Now we need to add the correct number of hydrogen. I have 1 hydrogen plus 4 hydrogen is 5 hydrogen. And over here I only have 1 hydrogen. So over here I need 4 H plus. I'm going to try and do this all in one line so this doesn't take like pages and pages of work. Okay, and now my charge on the left-hand side, I have a -1 right there. And on the right-hand side, I have -3. And I have +4. which gives me a grand total of +1. So I need to add enough electrons to the right-hand side that my charge equals -1. So to get from +1 to -1, how many electrons do I need to add? I need to add 2 electrons. Yes, very good. Okay, so that's going to be, and I've left myself enough room in here to do it, so I'm going to do that so I don't have to erase on the outside there. That's good. Okay. Now we have balanced our 2 half reactions. So we split it into 2 half reactions. We've balanced the 2 half reactions. Step number 3, what do we do next? What comes after balancing the half reactions? There's a step before we combine them. Combine is step 4. What is step 3? Yeah, we need to find the LCM. Let's make the electrons balance. Okay, LCM, make the electrons balance. Okay, or make electrons in equal electrons out. So let's take a look at our 2 sets of electrons here. I have 6 electrons on the left and 2 electrons on the right. What if I had had both half reactions with electrons on the right-hand side? What would you say to yourself if both half reactions had electrons on the right-hand side? If both half reactions were giving off electrons. What it would mean is you've done something wrong. Okay, you've made a mistake somewhere, because anytime you're balancing, you should always have one reaction, which is gaining electrons reduction, and you should have one reaction, which is losing electrons oxidation. If you don't have that, then what's going to happen is you are going to have, what am I trying to say? Yeah, if you don't have that, then you are going to have problems. Yeah, you've made a mistake somewhere. Okay, so let us now multiply that. Okay, so we now have, let's see, I'm going to multiply it in blue. Sure. Oh, I don't need to multiply the top one by anything because the lowest common multiple of 6 and 2 is 6, so the top one can just stay as it is. The bottom one I'm going to multiply by 3, and I'm going to rewrite that out as 3 times 1 is 3 HXeO4 minus plus 3 times 2. If you remember I did this last time, when I do it on the overhead projector, I can point my finger on it and you can see me pointing my finger. I'm putting dots above them so you can see me doing it. 3 times 2 is 6 waters. Otherwise, I have a tendency to forget to multiply something. So 3 times 2 electrons is 6 electrons. 3 times 1 is HXeO6, 3 minus, and 3 times 4 is 12 hydrogen. Okay. And I'm also going to, our next step, like you said before, Deborah, after we've gotten the lowest common multiple and we've made the electrons balance, the 4th step is now we're going to recombine. Okay, now we're going to recombine. Oh, HXeO3HXeO6. Yeah, see, I didn't even write it down. What an idiot. Ha! There we go. 3 HXeO6. I even said to do it and then I didn't do it. Crazy me. Okay. In order to make my adding easier, I'm going to copy this one down here just so I don't have to jump over the one in the middle. So I have Cr2O7, 2 minus plus 14, H plus plus 6 electrons goes to 2 Cr3 plus 7 H2O. And now I'm going to take these two and add them. So I'm going to cancel out anything I can cancel out. I can definitely always cancel my electrons. Is there anything else I can cancel out? Yeah, I can cancel out my water. You also have the choice of canceling after you've added, or you can do it here. So I know there's 6 water over on the left-hand side, and there's 7 water over on the right-hand side, so I can cancel 6 of them, and that leaves me with 1 water over here. Is there anything else I can cancel before I add? Yeah, the hydrogen ions. Okay, I have 12 of them on the right, and I have 14 on the left. You can only cancel them if they're on opposite sides. If they were on the same side, you'd have to add them together. You would have to combine them. Remember, it's only if they're on opposite sides you can cancel them. And so that'll be a 2. Now let's put it all together. So we have 3 HXeO4 minus plus Cr2O7 2 minus plus 2H plus, and then everything else on the right hand side is gone. So I've done this one and this one and this one, or sorry, on the left hand side. On the right hand side we have 3 HXeO6 3 minus plus 2 Cr3 plus 1 water. Oh, why did I write the 1? Okay. And that would be all if we were asked to balance it in acidic, but we were asked to balance it in basic conditions. So we need to make it basic now. So this is just exactly like the process that we did for half reactions. Do you notice in our full reaction though, there's no electrons in there? They should always cancel out completely, okay? Okay, 2 hydroxides here are going to cancel with those 2 hydrogens. And we also need to add 2 hydroxides to the other side. Never add hydroxides to one side only, always add it to both sides. So we have, just adding up now, 3 HXeO4 minus plus Cr2O7 2 minus plus these 2 together make water. So that's 2 waters goes to 3 HXeO6 3 minus plus 2 Cr3 plus 2 OH minus, and I'm running out of room here, plus H2O. However, I think that H2O is going to cease to be a problem because I see that I have H2O on the left and I have H2O on the right. So I have 1 on the right, and that can cancel with 1 of them on the left. And then that will be my overall reaction. Okay, so it's really step 1 and step 3 that people forget. Step 1, you have to split them. Okay, so don't forget to split them. Step number 3 is the other one. So if 50% of the people are making their mistakes at step 1, the other 50% of the people are probably making their mistakes at step 3, and they are forgetting to find the LCM of the electrons and make the electrons going in equal the electrons going out. So steps 1 and 3, super duper, 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 duper important. Okay. So this week your homework is going to be, let's see, balancing full reactions, numbers 1 through 5. Okay, and I don't see you again until next Tuesday. So our next meeting is next Tuesday. And that will be at 9:30. And I don't know what the date is on that. Today is the 26th, I think. 26th. Okay, and if we can, we'll fit in another session on the Friday at 9:30. That's our, what you call it, day, flex day. We'll see how that goes. We'll confirm the Friday session on Tuesday. I noticed that a lot of you haven't actually even looked at the assignment for last week, which probably means that if you didn't look at it, you may have missed. You may have just been like, oh, hey, I wrote down the oxidation number worksheet questions. I wrote down the balancing half reaction worksheet questions. And then I forgot that Ms. Spence said she was going to add something in. So I just did the questions and I was all done and blah, blah, blah. There's actually this extra one. So I'll put it back in this week just in case you didn't get a chance to do that last week. Okay, in case you missed it. So balancing full reactions, 2 applications of oxidation numbers and half reactions.